Now it's time to focus our attention on some definite integrals, and you've seen Sal on Khan Academy tackle some of them. Oops, sorry, I'm moving my screen around here a little bit. And I'm just going to go through a couple more examples so that you can be ready to tackle these yourself. Again, I am looking for the inside function, and I'm going to let the inside function be 4 plus 3x. In other words, I'm going to let u be 4 plus 3x and see how that goes. So I'm going to take the derivative, which is just going to be 3, and I'm going to move the dx over to the other side. And now I'm going to try and replace all of this with u's. So that means that this is just going to be u to the half, and I need to replace, so I've replaced all of this. Now I need to replace the dx, and the dx is sitting right here. So that means that 1/3 du equals dx. So now I can replace the dx with 1/3 du. So I'm going to put the 1/3 out front and the du. The next thing I need to make sure I replace are these two limits. They are in terms of x in the original question, but now we've switched things to u, so we need to make sure those limits change as well. So I'm going to plug 0 in right here, and I get 4 plus 0, so the lower limit becomes a 4. When I place a 7 in here, I get 4 plus 3 times 7, which is 21 plus 4, so the upper limit is 25. And now I've got everything in terms of u, so I can actually go ahead and take the integral. So the 1/3 is a constant and stays put. I'm going to increase this power by 1, so I get u to the 3/2 and divide by 3/2, which is the same as multiplying by 2/3. So I'm flipping and multiplying at the same time. I don't have to add the integration constant because I've got a definite interval, and I'm evaluating it between 25 and 4. So now I'm going to actually do the calculation. I'm just going to give myself a little bit more room here, erasing this bit, and now plugging in. I get 1/3, 25 to the 3/2 times 2/3. Let me multiply these two together actually first. So that's 2/9. So there's my first term, minus 2/9, 4 to the 3/2. Now it's time to evaluate this. This is 2/9 the square root of 25 cubed minus 2/9 square root of 4 cubed. So square root of 25 is 5. 5 cubed is 125. So I've got 2/9. I'm going to factor the 2/9 out. 2/9, and that's 125 minus, here we've got 4 square root of 4 squared. 4 is 2, 2 cubed is 8, minus 8. So my final answer is 125 minus 8, which is 117. So 2/9 times 117. And then you can either change this to a decimal or to a simple fraction. That's up to you. And you should get, oh sorry, you don't even need to, it actually works out to be 26. So let's move on to another example. Here I've got something involving exponential functions, and I'm going to let my u be this function right here, because the derivative of negative x squared is 2x. And that's pretty close to what I've got here. It's off by a constant, but constants aren't really hard to deal with. So we're going to let u equal negative x squared. So du by dx equals negative 2x. That means du equals negative 2x dx. Now I'm going to replace all of this with u's. So let's start with replacing the limits. When x is 0, u is 0. When x is 1, u is negative 1. And now I'm going to replace this expression. This is a u, so it's e to the u, and dx times x is this piece right here. So I need to move this over to the other side before I make a replacement. So negative 1/2 du is the same as x dx. So now I can replace these two bits here with a negative 1/2 du. So the negative 1/2 I'm going to put out front, du. Right now, taking the integral, the negative 1/2 is just a constant. The integral of e to the u is e to the u, and I'm evaluating it between 0 and negative 1. So at negative 1, it's negative 1/2 e to the negative 1 minus negative 1/2 e to the 0. Simplifying one more time, this first term is negative 1 over 2e, and the second term is plus 1/2. So you could write that as a common denominator if you choose. That would equal, let me skip up here, that would be equal negative, the common denominator would be 2e, so this would be negative 1 plus e. Plus e. There we go. There's your final answer. So moving on to yet another example, and the last two are kind of a trick questions. So you might say, you know what, this is equal to negative pi over 3, and that's sine theta to the 5th d theta. So you might say, hey, I'm going to let u equal sine theta, because that definitely looks sort of like the inside function, and I'm going to take the derivative, which is cos theta. But notice that there's no cos theta anywhere in this expression, so I'm kind of stuck there. And sometimes you've got to go back to what you know from integrals, and that's why it's a little bit of a trick question. The sine theta is a odd function. And if I take this to the power of 5, it's still going to be an odd function. And if it's an odd function, then, and I'm going from the same spot on either side of the y-axis, so from negative pi over 3 to pi over 3, it's symmetrical. So notice that this area will equal this area, and they will cancel because one's positive and one's negative. So because this is an odd function, we don't actually have to do a substitution at all. We can just say that it is 0. That's because these span the y-axis symmetrically. So just watch for that. If you get stuck and you don't see any solution for substitution, think a little bit outside the box. And that's going to be kind of the same thing to think about here. You might be able to say, hey, you know what, u equals 2x minus 3, and go on with your process there, and you would get an answer. But the problem is that between 0 and 2, x is going to equal 3/2. And when x is 3/2, this is undefined. And when it's undefined, you can't take the derivative or the integral. So this integral actually does not exist. So just be careful that you always take spanning variable limits here. The limit includes everything that is defined.